In this lecture, we're going to look at buffer systems or buffer solutions. Now to begin, let's suppose we have a system of 1 liter of pure water that has a pH of 7. Let's examine what happens to our pH when we add a small amount of acid or base to our system. Well, let's begin with the acid. Suppose we add 0.01 molar of HCl to our 1 liter system. Let's see the new pH. Well, the pH is equal to negative log 0.01, and that gives us a pH of 2. That means if we add this little hydrochloric acid, our pH drops by 5 increments. That's equivalent to a 100,000-fold increase in the hydronium concentration of our mixture. So now let's add the same amount of sodium hydroxide, a base, to our system. What will be the new pH? Well, first we calculate the pOH, and the pOH is equal to negative log of 0.01, it gives us 2. Now we subtract 2 from 14, and we get a pH of 12. That means our pH increases by 5 increments. That's equivalent to a 100,000-fold increase in the hydroxide concentration. That's a very big increase in pH. So the takeaway from this is that adding a small amount of acid or base to pure water will drastically change the pH of water. Now, if you're confused about how we got this part or this part, check out the link below. Now, aqueous solutions, unlike pure water solutions, resist changes in pH when we add acid or base. And that's because aqueous solutions have buffer systems. And a buffer is simply a chemical system which resists a pH change. So for example, suppose we had a system of 0.5 molar of acetic acid mixed with 0.5 molar of sodium acetate in 1 liter of water, and this system's pH was 4.74. So now what happens to our pH if we add 0.01 molar of hydrochloric acid as we did in part A? Well, now our pH will only decrease from 4.74 to 4.72. That's a change of 0.02. That's a very small change. Well, that's because this system has a buffer system. And buffer systems are really important. For example, our blood is a buffer system. And if our pH of our blood decreases even slightly, we will suffocate and die. So these guys are very important. Now let's see why this happens. Now before we look at how they work, let's look at why they work. What are the few requirements of buffer systems? Well, first we have to have a weak acid and a weak base. And second, the weak acid cannot react with our weak base. Because if it did, our buffer system would be neutralized and we wouldn't have a buffer to work with. Now what's one thing that satisfies these two requirements? Well, that's a conjugate acid-base pair. Whenever a conjugate acid reacts with a conjugate base, it produces another conjugate acid and base pair. For example, acetate ion and acetic acid react to produce acetate ion and acetic acid. So a conjugate base pair reacts to produce another conjugate base pair. So nothing is neutralized and our buffer remains unchanged. So normally, buffers contain equal amounts of conjugate acid as conjugate base. For example, in this buffer system, we have the same amount of acetic acid as the acetate ion. Now some exceptions do exist. For example, our blood. Our blood has much more conjugate base than conjugate acid. But that's because our body produces many more acidic byproducts than basic byproducts. And so we need more base to neutralize our acid. Now let's see how these buffers work. So for example, suppose we had the buffer system above, composed of acetic acid and acetate ion. Now suppose we add a strong base, such as sodium hydroxide, to our system. What will happen? Well, this base reacts with our conjugate acid to produce back the conjugate base and water. So before this base can affect our system, it's neutralized into a water molecule. So our pH only changes slightly. Likewise, let's see what happens when we add acid to our buffer system. Well, hydrochloric acid first reacts with water, producing hydronium ion and the Cl ion. Next, this acid molecule reacts with our conjugate base, forming water and back our conjugate acid. So once again, before this acid molecule can affect our solution, decreasing our pH, it's neutralized into water and our conjugate acid. And that's how buffer systems work.